Alright, so I'm probably gonna have to separate this into two more sections because doing the calculus is gonna be another 3 hours. So let's start here. The timer. You're a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer array, nums representing the amount of money of each house, return the maximum amount of money you can rob tonight, without alerting the police. Output 4, house 1, money equals 1, house 3, money equals 3. Total amount 4. So it's pretty much the same logic, but the issue is the path again. I don't remember really well how he did it. I think he did it with the using true path pretty much in the temp variable. The val1, then he made val1 equals plus equals something, and then he made val2 equals temp. Val1 or val2, I think was something like this, and then for I range nums, something like this, the previous one. But I don't remember really well. So again, it's gonna be the same thing where it can be divisible into a decision tree, and you can memorize the decision tree by keeping track of the points you already visited. But I'm still not at the point where I can remember how to structure the tree or to do the recursive thing. I think if I create a set, maybe I want to scratch this from the previous exercise. Visited equals set DFS. I call DFS even though it might not be. Yeah, I remember he started from the top and then did -1 on each one. The thing here is that it can only go. I have to jump between. I need a step of 2 for the decision tree. So if I start at 2 at the first index, I can only go for the second and then the fifth. So if I start at 2, I can go to 9, and then from 9 to 1. If I start at 7, I can only go to 3. Maybe I can call recursively, I can say stop here, and at the end call recursively with +2. So step would be the first index. And then if stop greater than length nums, or greater than nums, no length nums, I return, are equal, maybe. Otherwise, I have a value total here was 0. It's gonna be nums stop total is equal to nums stop. Yeah, so the only condition is you have to stop in 2. So if I start at index 0, I go by 2, index 1 by 2. And then I have to append this. And yeah, the only trick here is how do I know I visited all of the stops? Huh. How do I know I visited all of them? Maybe I don't need to. I could just call like this and then because I'm gonna start at the 0 index. So if I do, but I suspect it's not gonna work. Nose, length nose, DFSI. And I'm gonna turn this into a list if I can get the maximum like this. So that should be it. I don't understand this. And it's probably not the correct way. Because I also think I can do this with a for loop. This is pretty much the same thing that I'm doing here. So I'm missing the point probably. So maybe Oh, this. Oh, no, it's correct. And then here I can get the sum here. So return max. But then how I'm gonna compare? That's the thing. Because I'm thinking about doing this. So I'm pretty much storing all the numbers, or maybe I should do sum. Storing all the numbers in the set, and then, but then, yeah, there's also the thing that if I get the same amount in two different houses, I can't use the set really. So maybe I should do just a list. And then I just append to the list. I forgot about this, and where's this one? So this goes until it gets to the final, to the end of the list, and appends the sum, and returns the sum. And then here I put total equals 0. Call this then make total equals max total b visit total. And the thing is that it doesn't make any sense doing recursively if I do it like this, because it's better probably to loop. It's pretty much the same thing. But I'm probably doing something wrong here. I don't get why this is. Should be 4 here. I don't understand. Then print B. Why am I getting 6 here? What if I just returned this instead? Hmm. I'll decrease the light because it's bothering. It's hurting my eyes. Yeah, I have no idea. I'm just gonna look at the solution again.
Okay, let's solve LeetCode 198 House Robber. In my opinion, this is such a good question to understand. Even though it's just an easy question, you can learn so much about dynamic programming from this problem. And you might already know, Google really loves asking dynamic programming problems, and if you want to get started on that, this is such a good question to understand. So we're basically given an array of integers, like many problems, and each integer represents a house, right? So this is a house, this is a house, this is a house, they're all houses, and they're adjacent to each other. So it's basically a neighborhood. We want to rob houses to maximize the amount of money we can rob, so why not just rob all of them, right? Nope, there's a restriction. We can't rob two houses that are adjacent to each other. So we can rob this house, but then we can't rob this house, right? So we have to rob this one next, maybe, right? On the other hand, if we rob this one, we can't rob this one, and we can't rob this one. It has two neighbors. This might sound really difficult, right? So let's just start out with a brute force approach. Let's imagine if we were trying to get every single combination. Okay, so the first combination is where we pick the first house, right? So let's draw out what the decision tree of that would look like. Okay, so our first decision was to rob the house with value 1. Okay, so next we want to rob more houses, right? But we can't rob this one. So we have to basically get the max we can rob from these two. So does that sound kind of like a subproblem? Yeah, but we'll get there in a minute. So continuing on with just a brute force, right? Okay, so now we want to rob these two houses, right? Well, we can't rob both of them because they're right next to each other. So we can either rob house 3 or we can rob house 1. So this is the decision tree, right? And so along this path, so if we were to rob house 1, right? Let's say we went along this path. Then we can either rob house 1 and 3, or we can rob house 1 and 1. Obviously, we're going to choose this one because that gives us the total, that gives us the maximum, which is 4. Okay, but what if we didn't rob the first house? We decided to rob the second house. So that would be our other decision in our decision tree, right? Rob house 2. Okay, now we have not many choices, right? We can't rob house 3. So the only house left is house 1. So we rob that one as well. So if we went along this pathway in our decision tree, we would get these two houses robbed, and that's a total of 3. But we remember we found this, which was a total of 4, which is greater, of course, so that's going to be our result. Now, this is a very brute force approach. Imagine if we had more numbers here, right? Maybe a 3 and a 4, then we'd have to have like more paths in our decision tree. This could get very complex. So how can we improve it? Can we identify any subproblem? And the answer to that is yes. Let's take a look at the subproblem. So remember, we have two choices. We want to get the max that we can rob from this entire neighborhood. So the first choice is we rob from the first house and then find the maximum from the remaining houses, right? Imagine there's more houses here. There could be a 3, a 4, whatever, right? This is the subproblem. We're finding the max of a subarray of the entire array. The second choice we have is we skip this house, right? If we skip it, then basically we're saying, okay, find the maximum of the entire subarray, not including the first value. So let's actually write out the relationship if it doesn't make sense yet. So if we want to find the max we can rob from the entire array, we have two choices. Rob in this case indicates the max that we can rob from the entire array. So in our first decision, we decided that we were going to rob the first value. So array of index 0 plus rob the remainder of this blue portion of the array. So we're skipping index 1. We're going to rob the entire array from index 2 to the end. So I'll say n is the end in this case. So that's our first decision. If we decided to rob the first house, then we're going to break up the problem into a subproblem. Now we got to rob the remainder of that array, skipping one of the values. If we didn't rob the first house, then we simply only have the subproblem, rob every house, skipping the first house. So we start at house 1, not house 0, and go until the end of the array. So this is the recurrence relationship. You might not know exactly what that means, but it's basically a way to break up dynamic programming problems. Notice the result of the entire problem depends on only these two. If we can compute these two, then we have our result. But notice each rob can be broken up into its own subproblem just like we did over here. So let's actually solve the subproblems now before we solve the entire problem. Now I could do this in reverse order, right? I could say, let's find the max of this subarray, and so on, but it's a little more confusing to do that, so I'm actually gonna do it in order. So let's start at the first house, like we've been doing. So if we rob this house, that's basically our base case, right? So we can decide to rob this house. In that case, up until this point, we could rob a total of 1. Okay, now we get to the second house. So what's the max we can rob up until this point? Well, we can decide to not rob this house and only rob this house if we wanted to. Or we can decide to not rob this house and only rob this house. 2 is obviously greater than 1, so I'm going to decide only to rob this house. Next, we get to house 3. This is where it gets interesting. So what's the max amount we can rob up until this point? So we have 2 choices again. We can rob house 3 and we can rob house 1, or we can just rob house 2. The max is obviously if we rob house 3 and 1, and in that case, we get a total of 4. Now we get to the last value, 1. So we can decide to rob house 1. And if we did rob house 1, then we would want the max we could rob up until these 2 values, meaning we want 1 plus 2, because 2 tells us what's the max we can rob from these first 2 elements. We can't include this one, because it's adjacent to 1. So one of our choices is 1 plus 2. That's choice 1. Or we can decide to not even rob house 1. We can just get the max of the entire first 3 elements, not including this one. In that case, we have what we would get from the first 3 elements right here. We already computed it. It's 4. So our choices are 1 plus 2 or 4. Obviously, 4 is greater, so I'm going to choose 4. That means we put a 4 right here. And this last 4 means that for the entire array, the max value we could get is 4 if we wanted to rob houses. So we can put a 4 here. But notice how we don't even have to store this entire blue portion for each value. Like for this one 4, to compute this, we only need to look at the previous 2 results that we computed. And the reason for that is because we could either decide to rob this one and rob the remainder portion of the array, not including 3, in which case we'd have the value computed right here. The other case is if we wanted the max we could rob from the entire array, we could decide to not even include this and just get the max from these 3. And in that case, the value would be stored here. So now let's look at the code. Since we only need to maintain the last 2 maxes that we could rob from, we'll only need 2 variables. So I'll just name them rob1, rob2. We'll initialize them as 0, because if we get an empty subarray, we want to return 0 anyway. So let's iterate through each of the houses we can rob. And now we want to compute the maximum that we can rob up until this value n. So I'm going to compute that in a temporary variable for now, and you'll probably see why. So the max we can rob up until now. In my case, I'm going to say rob1, or rob2 was the last house that we robbed. Rob1 was the one before that. So knowing that, the max we could get would be n plus rob1, meaning there's a gap between the current house and the previous house, or rob2, which includes the previous house. In case it's not clear, this is basically, let me just make a comment to show what I mean by rob1 and rob2. So rob1 is first, rob2 comes second, and then we get some more values, n plus 1, and so on. So if I want to rob n, then I have to rob 1 as well. I can't use rob 2. But if I want to do rob 2, I can include n because it's right next to it. So when we iterate to the next position, meaning we get here, we want to update rob 1 to now equal rob 2. So let's do that. And rob 2, in this case, wants to be updated to n. So rob 2 can now equal our temporary value that we just computed. At the end, we want to return rob 2, because by the time we get to the end, rob 2 will be equal to the last value, meaning that it will be the max we can rob from the entire neighborhood of houses. This is a problem you can learn so much from. Even though it's an easy problem, it might take you a while to digest exactly what's going on and to understand all the importance of this problem. So many dynamic programming problems are built upon this one. And let me know if you have any questions, because I feel like I might not have explained the recurrence relationship quite well enough.
I understand really well what's going on here, but I'm going to move on to the next one, because I'm trying to do this fast. But it's pretty much similar to the previous one. You're a professional robber planning to rob houses. Each house has a certain amount of money stashed. All houses at the place are arranged in a circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected. Contact the police to adjacent houses, given integer nums, representing the amount of money of each house. Return the maximum amount of money. Corruption night without alerting the police. So it's pretty much the same problem, but the beginning. So let me try to see if I remember. So temp max JSON 1, JSON 2 plus 1. It's gonna be pretty much the same thing as the other one, but the only difference is the end there.
Okay, let's solve LeetCode 198. Next we can rob at the end. We want to return rob 2, because by the time we get to the end, rob 2 will be equal to the last value, meaning that it will be the max we can rob from the entire neighborhood of houses. This is a problem you can learn so much from. Even though it's an easy problem, it might take you a while to digest exactly what's going on and to understand all the importance of this problem. So many dynamic programs.
Alright, so let's try to think about this from the solution of the previous one. So let me see if I understand this. Temp equals max. And let me just use n because it's the letter he used. And plus, so he gets the maximum of the first one. So it's gonna start with 0, so temp is gonna be equal to the first element in nums. Then rob1 becomes rob2, which is 0 in the beginning. Rob2 equals the previous one. So now it's maximum. I don't understand this at all, actually. Maybe we should print rob1 and rob2 here. I'm also a little bit tired because of all the other problems I solved today. Not solved, try to solve. Length.
1 to now equal rob2, and rob2 will be equal to the last value, meaning
It's on the same line, so it's easier to say. So it starts with 0 and 2. And because 2 is the first element, and rob1 is going to be 0. And then 2, because it's between 0 and 0 plus 2 and 0. Or no, it's 2 and 2. The maximum out of 2 and 2 is temp. And rob1 becomes so confusing. We should print temp here as well. So the first temp is true because the first element is true. And rob2 is 0. And rob1 becomes 0. And rob2 becomes temp, which is the first element. Then in the next iteration, n is 3. Rob1 is 0. So it's 3 on the first, and rob2 is true. So temp becomes 3. Rob1 becomes rob2. which is true. It doesn't make sense to me because the only rule is that you can't go to the adjacent house, and n is an arbitrary number, so it doesn't make sense to me to get the maximum of n plus. I guess Rob 1 and Rob 2 are the true houses, and n is the value. So that's another thing that I have to work on. That I get confused. I had the same problem on linked lists as well, with these temporary variables, the passing the value. So to perform certain operations is just confusing. This type of thing is a lot easier than the trees and grass stuff, but it's just confusing to think about. So the next house is gonna be the maximum between the first and the second, plus the value of the specific house. How is that different from the previous one? So Rob choose should be the final amount, which is gonna be temp. Also, Rob Shoe, I think it works like an accumulator. So if the value of the next house surpasses the previous one, then it replaces. So Rob 1 becomes the previous house visited. Rob 2 is the next. I still don't understand. Maybe I should try to solve it in a different way than the way that I did it. Or I can make a condition first and decrease the size of the list until the new list becomes a different one, and then run the loop, but I don't think that's gonna work. So doing like this, it's probably not gonna work. Index out of range? How is that possible? Huh, there we go. But it's probably not gonna pass on this one. Yeah. I think I'm just gonna look at the solution. I didn't understand really well the explanation for the previous one also. But obviously, like I said many times before, I'm gonna take a lot more
Hey
time
everyone, welcome back, and let's
on
write
each
some more
problem the next time I'm going through them.
LeetCode today. So today let's solve House Robber 2. We already solved House Robber 1, and I would recommend watching that video, or at least solving that problem first before this one, because this one is very similar. So basically the premise of the problem is the same. We're just trying to maximize the amount that we can rob, and in this case we have a street, aka an array. So this is our array. We want to maximize the amount that we can rob. The only catch is that we can't rob two values that are adjacent to each other, because it's like two houses that are together. We can't rob two houses that are right next to each other. We have to choose one, so we can either choose the 2 or we can choose the 3, right? So that's basically House Robber 1. Now there's one more catch with this problem. In this case, the houses are actually arranged in a circle. So we have this as our array, but really this is what our array is going to look like. The 2 goes to the 3 goes to the 2, and then the 2 goes back to the 2, right? Basically what we're saying is this last value is also adjacent to the first value. So it's literally that simple. That's the only difference between House Robber 1 and House Robber 2. And actually the good thing is you can reuse the solution from House Robber 1 to solve this problem, and I'm going to show you how. So let's just remember House Robber 1 first of all, right? So we have this array, right? We can choose the houses we want to rob, but we just can't rob adjacent houses. So I'll explain at least a little bit about how we solved House Robber 1. Basically, it's kind of dynamic programming, and you can watch the first House Robber explanation if you want the basic, like the better explanation for it. But basically, okay, what's the max we can rob up until this point, right? That's 2, obviously, right? So we remember that. Okay, the max we can rob up to here is 2. Okay, what's the max we can rob up until here, right? Clearly, we have to make a choice. We can either rob 2, right, and then nothing from here, right? We don't rob here, and in that case, the max we could rob up until this point would be 2. But we know that rather than robbing house 2, right, we don't even carry this value forward. We just rob house 3, right? So then we can put a 3 here. So up until this point, the max we can rob is 3. Now, lastly, what's the max we can rob up until this point where we're looking at the entire array, right? Whatever value we put here is going to be our solution. So now we have two choices, right? We can rob house 2, skip 3, and then rob up until this point, right? And the value for here is 2, right? So 2 plus 2, we would get 4. Or we can make another choice. We can actually skip this house and just carry over the value that we computed before. What's the max we could rob from here, right? That's 3. We would just put the 3 here. Now, clearly, the first one that we computed was 4, so that's greater. The max we can rob for the entire array is 4. Now, I like House Robber 2 because it requires us to reuse the solution from House Robber 1 in a slightly clever way. It's not even about algorithms at this point.
it's more about reusing the solution. It's about, having a function. So the only restriction here, right, you see up here we robbed, like we were looking at, okay, what's the max we can rob from the entire array? The only restriction here is we can't use the same solution from here over here, right? The max we can rob from the first array is 4 with house robber 1, but with this, if we rob this, skip this, and rob this, we're not allowed to do that because remember the first and the last house is connected. Basically what I'm saying is if we rob house, like the first house, we can't rob this one. Or if we rob this house, we can't rob this one. How can we reuse the solution from up here? Let me show you. Let's say this is our helper function, right? House robber 1. We can basically say, okay, we can run house robber 1 on the entire array except the last value, right? And what's that going to give us? It's going to give us a 2, right? We can also run the house robber 1 helper function on the entire array except the first value. And that would actually give us a max rob of 3. I think for this one it would also be a max rob of 3, right? But basically what I'm saying is we have to run the helper function twice on different subarrays of our input array because we're not allowed to rob the first and the last house together. So if you actually understand house robber 1, right, the helper function that we're going to use, and you understand what I'm saying over here, right, where we're not allowed to rob both the first and last house, then all you have to do is call the helper function twice on these 2 subarrays, and whatever one is the max is the value we're going to return. You can see in this case, from the first array, the max you can rob is 3, right, if you rob 3 and skip the first house. And if you from the second array, the exact same thing is true because this is a pretty symmetrical array. So if you skip house 2 and rob this one, this 3, you also get a max rob of 3. So that's going to be the solution. But it could have been different technically, right? Maybe this could have been a 5, right? And in that case, the max you could rob from the first subarray would be 5, skip the 3. So then 5 would be our solution, right? And once you can basically identify this problem, it's pretty straightforward. And so since if you might remember, the house robber 1 algorithm is a linear time algorithm, O of n, all we're doing is calling that same algorithm twice. So the time complexity is going to be big O of n, right? And the memory complexity is going to be O of 1 because we don't really need any extra data structures for the most part. So now let me show you
So it is pretty much what I was doing. The only difference is that I didn't test with removing the first element instead of the last one.
Code, and it'll make a little more sense. So first, I'm going to create a helper function, right? Basically, what I'm going to put here is our solution from...
I still don't understand really well. It confuses me, the solution for the previous one, though. I'm going to have to spend more time on that later. Do you understand?
House robber 1. If you remember, we have 2 values, rob 1 and rob 2. Basically, these store the max amount you can rob from the previous 2 houses, right? And initially, we can set them to 0, right? We can just assume that there's 2 random houses that come before our input array, and both of those houses are value 0, or however you want to call it. But we are going to have to go through every number in the input array, every house, right? And so how are we going to compute what's the max we can rob up until this point? I'm going to store that in new rob, but you could call it something else. How are we going to compute that? Well, we're going to take the max of the current house that we're at, right? N plus rob 1, right? So rob 1 plus n, because we're not adding rob 2 to this, remember, because we have to skip rob 2, right? We can't rob 2 adjacent houses. We can't add rob 1 and rob 2 together because those houses are adjacent, right? N is adjacent to rob 2. We can't add those together. But this is one solution. We're skipping house 2. Or if we decide we do want to include rob 2, then we're not allowed to include rob 1 and we're not allowed to include n. The other choice that we have is just rob 2, right? So we want the max of these, which is going to tell us up until the current position that we're at in nums, what's the maximum we could rob. So this is the new rob, right? And since we're continuing to iterate through the array, we're going to continue to update rob 1 and rob 2. So since we're shifting by 1, we're going to assign rob 1 to the previous value that was at rob 2. And we're also going to update rob 2 with the value that we just computed new rob, right? And basically, once we've gotten to the end of the array, rob 2 will contain the max amount that we can rob from the entire input array. So after the loop, all we need to do is return rob 2. And so now that we've gotten our helper function done, we basically solved the problem, right? But there's just a couple edge cases you have to worry about. So we're going to call our helper function, right? And remember, one of the cases was we're going to skip the first house, right? So we're going to call the helper function skipping the first house. How can you do that? In Python, you can just say pass in the entire array starting at index 1, right? So we're skipping index 0. So we're skipping the first house, right? So that's one call that we're going to have to make to our function. We're also going to have to make one more call, right? And this time we're skipping the last house. So you can do that in Python like...
And then you take the max above, and then, yeah.
This, right? So -1 is basically the last index functions return first and only house if we only had one house in our input array. So we're actually taking the max of 3 values here. And one of those values is literally just the first house by itself. So the maximum of these 3 is going to be the max that we can rob. So then we can just return that value. The convenient thing about Python, at least, is that you can actually take the max of 3 values. And don't forget, that's all.
All right, so it's closer than I thought I was, actually. It's a good thing. I think I'm only going to do one more because I'm pretty tired at this point. And I'm either going to rest more and come back today, later, if I feel rested, or come back tomorrow only, because I think it's counterproductive to not even thinking that much anymore. It's better to rest more and then try again. Then to force myself to try to do this and not really even think or try. Given a string s, return the longest palindromic substring in s. So I assume it's going to be pretty much the same method from from previous ones. So probably going to make something like this. Next, or Turn the longest palindromic substring in S. So maybe I can create another function actually to get palindrome. And after that, I loop through the string, or through the initial string. Oh, it's probably not a good idea. Yeah, this feels very similar to the sliding window problems, where you have these two pointers advancing faster, one faster than the other, and keeping track of one another to find the palindrome. So maybe that is a possible way to solve it. But it feels like it's too complicated to do it that way, because you have to somehow keep track. Yeah, you can't really do it that way, I think. Because you would have to know the middle of the string previously, the palindrome string, in order to check with the sliding window if it is a palindrome or not, so it can break out of the window and continue in the main one. So maybe I have no idea how to solve this with backtracking, but I remember how to do the palindrome. You take the middle, the quotient of the middle of the string. Then you create two pointers and you check if they're equal or not. V1, V2, for letter in words. Oh, actually, it's better to use range for I range length words. I just need one pointer here, I think. Uh, I think that's pretty much it, and then here return to. So you're checking, and also you need to decrease by one. You start initializing one in the beginning and the other one at the end, and limit in the middle. And if they're all equal, then it means that it is a palindrome. But now the question is, how do I check in the first one if it is a palindrome or not? That's the thing. That's the reason why I don't think it is gonna be this way to solve it. Because you probably need to pass letter by letter somehow. But maybe it's a similar way to this, but so maybe I should do the same thing here, but in the first one, and instead of returning false, I can do something else if they're different. But the issue is that I'm always starting at the end and the beginning. So there could be a palindrome that is shorter inside of the string, and then I'm gonna miss that. So maybe I can use the 2-pointer technique as well here. Where I keep one pointer fixed and then I search in the remaining of the string for the condition, and if I can find a palindrome, then I start moving the other one. But that would probably be bad, because then for each letter it's probably O square, N square. For each letter I'm doing one loop in the string. It's probably n log n actually. It's not n square, because the size of the string reduces after each iteration. So what else can I do here? So maybe let me try this 2-pointer stuff. Maybe and the problem is the condition. It's not quite the same thing. Because here I would increase and decrease based on the value of the list. And it has to be a sorted list as well. Maybe I can use the letter of the words, but I think that's most likely not the best way to do this. So here I would have a different list. Found. If yeah, but then I can't use this while loop. I also think that it might be possible to use that tabulation technique, where first you loop from left to right in the string, and then you keep the string, and then you reverse the string by looping on the other order, and then you compare both. Maybe that's a way to do it. That's the way to do it. Or you don't even need to do that. I think you can just do reverse s is equal to s minus 1. Yeah, so remember correctly. So maybe you can loop through both and then check where they're equal. Yeah, maybe that's the way. Yeah, if si is equal to reverse si, I have a count here was 0. I think I'm pretty close probably. Because if you think about it, the reverse should be equal to the for it to be a palindrome, the portion of the reverse should be equal to the portion of the normal string. Or maybe I'm tripping. Yeah, and then it's gonna break. But the issue is I'm counting twice. That's the thing. That's why it's giving me 6. Hey, and I don't wanna count. I wanna add the stuff to. And the problem is I'm not getting to the middle of the thing. Yeah. Plus max. Mm. It's not gonna be correct, but I just wanna see what do I get there. Yeah, I'm repeating twice. That's the issue. And at the middle as well. And if I do it like this, I don't think I can slice strings. Maybe I can actually. It's gonna give me the correct, but then I'm counting twice. What if I did length ras divided by 2? Yeah, but that's clearly not good. Not good. It's not gonna pass all the tests. I think it is probably true, but I also think it's not gonna work. But also, hmm. Don't get why this is not returning. It's equal to true, and because it's different. Yeah, whatever. I'm gonna look at the solution and then I'm gonna stop here.
Hey everyone, let's solve another classic LeetCode problem today, longest palindromic substring. So we're given a string, in this case, BABAD, and we want to return the longest palindromic substring that exists inside of here. In this case, there's actually two, BAB as well as ABA. So we could return either of these and that would be perfectly fine. Now, what actually is a palindromic substring in the first place? Basically, it means that, you take BAB, if we wrote that in the reverse order, which would be, BAB, it's the exact same string. So like I usually do, let's say you just don't know how to solve the problem. Well, what's the most brute force way you could do it? Well, you could say, I'm just going to check every single substring in this original string and check if it's a palindrome and get the longest one. Starting at B, so I would check this, I could check this, I could check this, and this, right? So every substring containing this original B. And I want to check for each of these, is it a palindrome or not? And I would repeat that process with every character, right? So for this A, I'd get every substring and basically keep doing that. Now, the question is, for a string, for example, BAB, what's the time complexity to even check if it's a palindrome? Well, we'd have to scan through the entire string, right? So for any given substring, to check if it's a palindrome, it's going to take linear time complexity. So let's say n, right? Now, how many substrings do we actually have to check? N squared, because we're checking every single substring containing every single character. So to check if a string is a palindrome, we have to do a linear scan, and we have to do that for every single substring. So then that's going to mean that the overall time complexity of this brute force approach is going to be big O n cubed. So the question is, how can we do better? Well, it actually involves understanding how to actually check if a substring is a palindrome or not. Again, let's look at BAB. We can check if it's a palindrome by starting at the outside and comparing these characters. And as long as they're equal, we'll keep going until we get to the middle, and then we'll know, okay, it's a palindrome. But we could also do it another way. We could start at the middle and then expand outwards and check if it's a palindrome that way. So which one of these is going to help us more? Well, let's think about this. Let's say I wanted to know, for this B, what's the longest palindrome where this B is the center of the palindrome? Well, there's no character to the left of it, so it's just going to be this character, this B itself, right? So it's just one. What about this A? Well, let's start expanding. There is a character to the left and there is a character to the right, and they happen to be equal. So the longest palindrome with this A at the center is going to be length 3, and it's going to be BAB. Notice how if we do it this way, for each character, we're going to consider it the center, and we're going to keep expanding outwards. We're going to take each character, so that's going to be n, and to expand outwards for each character, it's going to be n again. So for this way, the overall time complexity is going to be O of n squared. So that's kind of clever, right? Like a subtle difference of how we check if it's a palindrome can really improve the time complexity. But hold on, there's one edge case that we're missing. When we take one character and expand outwards from it, like for this B, we're getting palindromes that are of odd lengths. They've conveniently shown us this example where the longest palindrome is actually even. So how are we going to check even palindromes? Well, that's just a slight edge case that we can easily add to our solution. So we just have to remember to handle this edge case when we're implementing our code. Okay, so let's get to everybody's favorite part, the code. So I'm going to initialize the result as an empty string because, that's just a good default case. We'll get the longest length initially set to 0. Now we're going to go through every single character, or rather every single position in this string, considering it to be the center. So first, let's check odd length palindromes. So I'm going to have a left and right pointer. These left and right pointers are going to be initialized to I, which is our center position right now. While my left and right pointers are inbound, as well as while this is a palindrome, so I want to check that the left and right are equal to each other. Remember, we're starting in the middle and expanding outwards. So while this is the case, we know it's a palindrome, so we can potentially update our result. So we'll check that the length of this palindrome, which we can compute by saying right minus left plus 1, is greater than our current result length. Then we update the result. And we also have to not forget to update the result length. I usually forget to do this. And let's also not forget to expand our pointers outward. So our left pointer will be shifted to the left. Our right pointer will be shifted to the right. So now let's check the even length palindromes as well. Right now, you can handle this a bunch of different ways. The way I'm going to do it is setting the left pointer to I and setting the right pointer to I plus 1. So again, we're basically copy and pasting the code that we just wrote above. Maybe we could write a function to do this, but I'm too lazy to do that. So while it's a palindrome again, we'll check that the length we'll check that it's the longest palindrome that we've seen so far, basically. If it is, we update our result. And again, we can expand our pointers outward. And at the end, all we...
So it's very, very similar to the thing that I was trying to do, but I mess up on the substring here. I'm passing to the result. And this if condition here also, I didn't do it. I'm just pretty much checking if the sum is bigger than the length. Oh, just checking to see if the new one is bigger than the previous one, I think. So each time it finds a palindrome and it's searching for another one, it checks to see if the other one is bigger. But it doesn't make sense. I don't know. Yeah.
All we have to do is
Think
return
about it
our
then.
result. So I kind of made it look easy with the code, but don't let it fool you. It took me a while to write this before I started recording this. There's a lot of like edge cases that can be kind of annoying with this problem, I think. For me, putting the if statement, checking that it's the longest palindrome inside of the while loop helped, I think. If you put this outside the while loop, it kind of makes it harder.
Yeah, I'm pretty tired at this point. I wanted to keep going, but I think it's gonna be counterproductive, I think. We pretty much can't force it. It's better to work smart, not hard.
But I hope this at least gave you a little bit of the intuition behind the problem. Writing the code is not always easy, but if this was helpful, leave a like and subscribe, and thank you for watching.
So maybe I can come back later and try to do 3 other ones, but if not, then I think it's probably in 2 days. The 2 next days I'm gonna finish this list, and then I can focus on one thing at a time later and dive really deep into them. So maybe I'll be back today, later, or tomorrow. So see you then.